Hello, everyone. So this is an extra video about more example on multivariable function and for gradient and maximum of gradient. Not made maximum of gradient, maximum directional derivative. So we did in class like 2 variable cases, so we can do multiple variable cases. For now, we'll do 3 variable cases. So briefly review that. Okay, so if the differential function f(x,y,z), then we have gradient is still fx, fy, fz. And directional derivative will be similarly. So we have to change along 3 direction. And now u is ABC, and be careful, u is unit vector. So u is unit vector. And now if it's differentiable, then we can have directional derivative is the gradient dot the direction. So we use the exact same definition, then we can do this. And recall that the maximum of the directional derivative will be the gradient, will be the magnitude of the gradient, and that happens when they are the same direction. Okay, so let's do this example. So if f of x equals xyz equals this thing, and directional derivative of 1, 0, -1, when direction is 1, 1, -1. So again, the first thing we need to check that, okay, is the direction actually the direction? So we need that it has to be a unit vector. And we can see that it's not a unit vector. So the direction now will be v over magnitude of v. So it'll be 1, 1, -1, and square root of 3. So this will be 1 over square root of 3, 1 over square root of 3, -1 over square root of 3. And we can see this function is clearly differentiable since everything's polynomial, so it's differentiable. So we can happily use our definition. So d, maybe I write direction become u. So u is this one. So d u f 1, 0, -1 will just be gradient f at 1, 0, -1 dot u. So now we only have to find what is the gradient, and gradient evaluated at 1, 0, -1. So f is this, so we can happily write gradient f equals fx. So take derivative, then will just be 10x and 2xy, so it's just plus 2y, and there's nothing x on the third component. Maybe I'll write this. This is fx, fy, fz. So it will be this. And what about fy? So first term is 0, second term will be 2x, and third term will be 6yz. And what about fz? First term 0, second term 0. So finally, we only have 3y squared, -3y squared. That's it. So we just plug in the gradient. So this will be 10x, x is 1, y 0, so it's 10. And 2x will be 2 minus 6yz, y 0, so everything is 0. So it's 2. And -3y squared, y is 0, so this is 0. And dot this thing. So this will be 10 times 2, and the other thing is gone, so it's just 12 over square root of 3. We're done. That's it. So exact same thing. It's just follow the exact same thing. Just now we have extra term. We have to still take the partial derivative of y. And that's it. Okay, what about next question? If p is on fyz along this direction, it has a biggest directional derivative to square root of 3. And we have to find gradient and have to find a directional derivative. So when you see biggest directional derivative, and we also have the value, so we can happily say that along this direction, it has the biggest direction. So this direction u will be parallel to gradient f. Gradient f x, y, z at p. Okay, this is a thing. And we also have the length of the gradient. The length of the gradient, x, y, z, the magnitude of this one at p is 2 square root of 3. So that will reduce to the old problem. You give a vector direction, then and you have a length of the vector. We need to find that vector. And that's it. So if gradient f x, y, z is parallel to u is 1, 1, negative 1. So we can happily write gradient f x, y, z will be t times u. So in this case, will be t, t, negative t. And we also know that the magnitude of the gradient, it will be the magnitude of the t, t, negative t. So it will be t squared plus negative t squared and take square root. So will be 3t squared will be 2 square root of 3. This is 2 square root of 3. So we'll just try to solve it. So 2 square root of 3 is just 12. So in this case, 3t squared equals 12. So t squared equals 4. So t's will be positive or negative 2. Be careful. Should we choose positive or negative? So positive means that it's the same direction. Negative, it will be opposite direction. And now we have the biggest directional. So it is same direction. It is same direction. So t can only be 2. So t is 2. So t is 2. T is 2. So we're done. So finally we have gradient f x, y, z. We plug in t equals 2. Will be 2 to negative 2. And the directional derivative f x, y, z, it would just be gradient dot the direction. But be careful. We don't even have to do this. It's given to you. It's already given to you, right? Oh no. It's already given to you. It's already given to you. You don't have to do this. Of course you can do this, but this guy is just 2 square root of 3. We don't even have to do the calculation. It gives you the biggest directional derivative. So it's 2 square root of 3. So this part B just asks you how to know the definition of directional derivative is du, and that's it. You don't have to do this. So don't be fooled by the question. You don't have to do this. Du is just directional derivative, so it's 2 square root of 3. And that's it. So I think this is a good question. So I strongly suggest to do it by yourself, since you have to know, okay, it's same direction, it's gradient, then how do you deal with the gradient? And that's it. So that's it for some extra example, and I'll see you in the next video.